Hello and welcome back. There's only one possible reason why you clicked on this video, and that reason is to fully understand the solution of this problem. And there are a lot of resources out there where you could just look at the code, but as I said, once you come to this channel, I want you to fully understand the pattern and the solution behind the problem, so you could take that with you and apply it on a multitude of similar problems out there. So let's go through the description of the problem and let's see what's expected from us. We're given a binary array nums. So binary, it means it's just 0 and 1s in this array, and an integer k. And we're asked to return the maximum number of consecutive ones in the array if we can flip at most k zeros. So by looking at the first example, we see k is equal to 2. So we're allowed to flip 2 zeros into 1s, or just consider these 2 zeros as 1s. And then we're asked to return the maximum number of consecutive ones. So the challenge here is, what about if we have more zeros than k? We don't know then which zeros we should flip. We could flip the first two, or we could flip the last two, and so on. So let's get into the whiteboard and let's see how we can solve this problem. So I simplified a little bit this array, so just to fully understand the solution of the problem. Let's think about what would be our most intuitive way, the easiest way how we would solve this problem, the brute force approach basically. And I recommend you to think about brute force approach before you think about anything else. And you could build on top of that. So probably brute force approach would be to try to compute every single subarray out there and try to get every single possible answer. But that would be very time consuming, right? So we could do this problem in a linear time. We will just traverse this array once, and by the end of the iteration, we would have our result. So how would we do that? So look at this example right here. And our k is equal to 2. So we know we could flip at most 2 zeros. So we could have two possible answers in this situation, right? We could flip the first two, or actually we could have three possible situations. We could flip the last two, right? Or we could flip the first one and the last one, right? And we're asked to see what would be the maximum number of ones which would be consecutives. So in this case, we would see basically the length, the greatest length would be the second option, because we would flip this 0 and this 0, and then our answer would be 6. In this particular case, the first one will be 5, and in this case, we'll have a 4, and then we'll have a 5. So basically, we need to pick this 6 right here, right? So let's think about this now. We need to start at the beginning. So we'll have a pointer, a left. So you saw when I drew this, we're like, for example, if we're picking the first two, so we know that this is our left and this is our right. So that's why we'll start with this pointer approach. So we'll have two pointers and both of them will start at the beginning, right? Left and right. So right now we need to check, do we have any zeros? Because if we don't have any zeros, we could just keep going towards the right. As we said at the beginning, we need to traverse the whole array. So right now we don't have any pointers, right? We don't have any zeros. So our result so far will have a variable result so far, and our result so far will be equal to right minus left plus 1. And why is that? Because, for example, if we have a sequence like this and we're asked to return the length of this sequence, and this is start and this is end, we know that the mathematical equation is n minus start plus 1, right? That will give us 3 minus 1 plus 1. That will give us the length of 3. So we have our result so far, which is equal to right minus left plus 1. So both of them, left and right, start at 0. So our result so far is 1. And then we would have a variable result, which will be basically the maximum result that we will have to return at the end. So this will be the max between our result and our result so far, right? Because we could have a result so far. Right now our result is 1, but we don't know that. Well, we don't know how we'll update this result if we'll continue to traverse the array. So right now the result so far is 1. So we said we're going to move our right. So our right becomes 1. And still no zeros. We're allowed 2 zeros. So our result so far becomes 2. We're going to move our right again to 2. Our result so far becomes 3. And then we're going to move our right again. And once we made it to this point, it's starting to become interesting because we have a 0. We found a 0. Now, are we allowed to have a 0? We are. We are allowed to actually have 2 zeros. So we're going to keep track of how many zeros we found. So right now we found 1, and we're going to consider this 0 as a 1. So we're going to keep going with our result. So our result right now is going to be equal to 4. And then we're going to move our right. Again, this is our right now. And this is the last 0 that we can consider. We only allowed to consider 2. So we're going to update number of zeros 2. And our result right now becomes 5, right? Because we could consider these 2 zeros as 1. So right now we are looking at this example right here. So our result so far is 5, right? This portion of the array, our result is 5. Now, if we move to the next element, our right becomes 5. We know that we have another 0. So we have 3 zeros. And we know that we're not allowed to have 3 zeros. So we need to get rid of 1 0. So let me ask you, we already know the result so far here, right? This is 5. So obviously we need to get rid of a 0, but which 0 are we going to get rid of? Because if we're getting rid of this 0 right here, then there's no point because our 2 zeros right here are already taking care of this condition right here. So anything that we found after is not going to be valid. So if we want to get rid of a 0, we should be getting rid of a 0, the first 0. So we could look from this point all the way until the end because we don't know what's going to be all the way until the end. So the way how we're going to do that is just to move our left pointer. So our first position where we found our first 0 plus 1. So our left pointer is going to move to whatever we found our first 0 because we're getting rid of that 0 plus 1. So our left pointer is going to move here right now. So right now we're going to look at this window. So basically that's the pattern, the sliding window, right? So the first window that we looked, it was all the way here. And right now we are going to look at this window. So we're getting rid of this 0. So right now we're going to look at this window. We don't know yet how far we're going to go, but we're going to look at this window. So our left becomes 4. And we keep going with our right. And if we gonna keep incrementing our right, then we're gonna see that our result is so far is gonna become 6. And since 6 is greater than our result, we'll update our result because we're gonna consider this 0 and this one, and we have 4 ones right here. So the length of this window is greater than the first one. So this is how you do the sliding window. You're basically moving, we need to expand or contract. So in order to expand our window, we're just gonna keep going as much as we are in this K condition. And by the way, after we're getting rid of this 0, our number of 0 is gonna decrement. So right now we have 2 again. So if we're finding another 0, potential 0 right here, we're gonna increment it again, and then we're getting rid of this 0, and then the next sliding window is going to be from here all the way here, and so on. So basically we're moving this window, we're having a left and a right pointer, and we're moving this window towards the right, and we're keeping track of the result and the result so far. And once we've reached the end of the array, we're just gonna return result. So let's get into the Leetcode. Let's code it super quickly. I think it's gonna make a lot of sense once you're gonna see it in the code. So we know we have some pointers, right? So we have our left, and is starting at 0, and we also have our right, and that's also starting at 0, right? And we said we need a variable to keep track of the number of zeros. So num of zeros, and that's 0 so far because we haven't seen any. And then we'll have a integer result, and that will be we'll initialize it to min val. Nice. So right now we know we need to traverse the whole array. So we could say while our right pointer is less than num's length, so we need to do some processing right here, right? So we're gonna check first if nums of right is equal to 0. Then what we're gonna do is gonna increment our num of zeros. So our num of zeros plus plus. So if our num of right, we're starting here, and as soon as we found 1 0, we're gonna increment this number of zeros. And after that, in the case that our number of zeros is greater than our k, so what we need to do now is move our left to the first position. So in this case, the first position where we found our 0 is 3, so we're gonna move our left to 4, right? So while number of zeros is greater than k, what we need to do here is check if our nums of left is equal to 0. So if we found our first 0, we're gonna decrement our number of 0, and then we're gonna increment our left. So we're gonna keep going with our left until we found the first 0, and then that's gonna be our left. So all we have to do after this iteration of the loop is to create a variable result so far, which is gonna be equal to right minus left plus 1, as we said, and our result is gonna be equal to maximum between these two. So math that max between result so far and our result. And at the end of the loop, we need to do one more thing right here. We need to increment our right. Or I guess you could have done this in a for loop. And all we have to do now is just return our result. And I think that should be it for this problem. Let's submit. And what's our time complexity? As we said, we made a very good improvement because our time complexity right now is going to be O of n, because all we have to do is iterate through this array only once. Yes, we're keeping track of these pointers, but all we have to do once our right made it to this point, we are done. We already have the answer. So time complexity, big O of n. What's our space complexity? It's O of 1, just because we're not creating any space. So that's it for this problem. If you have any questions or comments, please feel free to write them below, and I will see you thanks for watching, and I'll see you in the next video.